Hi everyone, welcome to Reinvent. I hope you're having a good day one. My name is Vaibhav Sethi. I'm a senior product manager on Amazon Personalize. And today we are going to be talking about how to create personalized user experiences using machine learning via Amazon Personalize. In a short while, I'm going to be joined on the stage by Emeric and Robin from Voodoo, and from Mark from Coursera. So Voodoo and Coursera are our customers, and you're going to be hearing more about how they have been using Amazon Personalize. So this is a special event for us, for all of us in the Personalize team. Amazon Personalize was launched as a preview service at reInvent last year. We went GA early this year, and we have been very encouraged by the kind of success we have seen customers achieve with this service. And we have two of such customers to talk about it today. So let's have a brief look at the agenda. So we start off with a brief overview of the business impact of personalization, followed by a gentle introduction to Personalize. Then we're going to go a bit deeper into how you can apply Amazon Personalize to a couple of personalization use cases. Then we're going to have Voodoo come on stage and talk about how they're using Amazon Personalize for their in-app recommendations, and how Coursera has been using Personalize for improving course subscription revenue. And then we go followed by a Q&A. So let's get started. Why personalization? So personalization has several material business benefits. The first business benefit is that it's a very elegant way of letting customers discover more of your tail catalog. So if you have a large product or item catalog and you want customers to find relevant items in there organically, personalization is a good way to do that. Personalization is also empirically proven to improve customer engagement. So this is typically measured in terms of CTR, in terms of watch duration on videos, if you're doing video personalization, in terms of dwell times on articles. And all this leads to increased engagement by the users. So typically, personalized user experiences tend to have a higher conversion rate. So for example, higher app downloads, higher number of people subscribing for your services. And this finally leads to increase in revenue, which is a metric I'm sure all of us care about. So the business benefit of personalization is fairly obvious, right? But the path to achieve this business benefit is not very obvious. So we have been doing personalization on Amazon.com for a while. So we started way back in 1998 with fairly simple customer experiences. So this is an example of item-to-item collaborative filtering algorithm-powered recommendations. So seeing what customers have in their cart, we recommend other items, right? So these kind of user experiences were very well loved by our customers. And from there, we started on a journey of adding more and more personalization to all kinds of user experiences on Amazon.com, on all other kinds of Amazon properties. And we have learned a few things doing this. So the first thing we learned with doing personalization is that rule-based personalization is very easy to get started on. It's very hard to get good results out of it. So an example of a rule-based personalization would be, let's say you are a shoe retailer, and you know the gender of the person visiting your website. Let's say it's a woman visiting in the month of December. So you populate your landing page with a bunch of boots, right? Regardless of whether that person is interested in boots or not. So it does make a somewhat intuitive sense. It is fairly okay approach to get started on when you don't have too many users, when your catalog is not very big. But as your catalog starts increasing in size, as your number of users start increasing in size, it's very hard to define rules which are specific enough so that they offer meaningful personalization, while at the same time they're not in conflict with one another. And once you define these rules, your work doesn't stop, right? You have to keep investing in these rules to keep them up to date with your business context, right? So it's a very effort-intensive approach. And what we see is that even though it is effort-intensive, it underperforms even simple machine learning techniques in terms of predicting the right outcomes for the users. So machine learning is the way to go, and we've seen machine learning perform very well for personalization. But naive machine learning also doesn't perform really well. So you need to sort out a few hard challenges in machine learning to get good personalization. So the first is that good personalization should respond to the intent of the user at that time. So it should be real time. So pre-computed recommendations, again, it gets you to some kind of performance, but to get really good performance, the recommendations have to be real time. And you need to handle scenarios of recommending relevant items to users who are new. You don't know a lot about those users. And to match new items, and to recommend the relevant new items for a given user. Right? So this is known as the cold start user and the cold start item scenario. You also need to avoid falling into a popularity trap. So naive personalization systems end up giving recommendations which are very similar to popular items. So it might feel like personalization, it's not truly personalization. The third issue or opportunity with personalization systems is that there is no one machine learning algorithm which is applicable for all personalization scenarios. So this makes the field really interesting, but also challenging because you have to experiment with several techniques and you don't really know if you're getting the best, you're applying the best algorithms for a given application. And also we have seen that even though personalization is ML 101, you typically need a data science expert to develop good personalization models. So given all these challenges, what we see is that most customers actually stick to rule-based personalization. Or worse, they don't do personalization at all. Right? So that's really a big missed opportunity. And we have been seeing these trends. And to actually help our customers in AWS to apply personalization to their business scenarios, we have been working on Amazon Personalize. So this is it's a service which is built on the lessons we have learned by operating personalization on Amazon.com. And it's available to you as a managed AWS service. And this service doesn't require any machine learning experience to get started and to solve the personalization problem. So let's quickly look at what's going on in Personalize and how do you start using it. So we start in Amazon Personalize by, you start with Amazon Personalize by ingesting your data into the service. So this is a very critical point to note. So all the models in Personalize are custom to your data and they're private to you. And we have three kinds of data which are relevant in Personalize. So we start off with what is called as user events, also called as interactions in our system. So this is essentially what the users are doing on your website or app. So what are they clicking on, what items they're adding to the cart, what are the purchases, etc. So this data set has the most signal for personalization, and this is the only one which is strictly required for going through this process. The other two are optional. So that's the first kind of data set. The second data set is item metadata. So details about your items, right? So let's say you're doing some product recommendations. So this would be price point of an item, the category information about an item. If you're doing video recommendations, it's the genre of the video, duration of the video, who is the actor in the video, for example. So you can optionally add this data. It's useful for cold start scenarios. And then similarly, you also have to add user metadata, so details about the user like their age, their location, their gender, etc. Now, once you get the data in, everything from there on is managed by Personalize. So you can go through this entire workflow in just a few clicks, specifically just 5 API calls. And you get to a hosted model, which you can then use to vend recommendations for your users. And the recommendations, the systems aspect is all taken care of. The recommendations respond to the real-time user activity. So this is a double click on what is going on in Personalize. So this is a very typical machine learning pipeline, right? So, but with Personalize, you don't need to worry about it. So we do the featureization on the raw data which you provide. You select something we call as a recipe. It's somewhat analogous to an algorithm. According to the use case you want to solve, and I'm going to go into the use cases in a bit more detail shortly. Then we take care of optimizing, training the model, optimizing the model on your data. We take care of hosting these models in an auto-scaling fashion for you. And we also have a real-time feature store. And this is essential because we keep capturing all the real-time information which is coming about your users. And then that's what allows us to change recommendations in real time. So this is Personalize in a nutshell, fairly easy service to get started on and to get value from. So let's see what kind of use cases you can solve with Personalize. So while building Personalize, we wanted to focus on foundational personalization use cases. And you can create a lot of user experiences with these foundational use cases. So the first one we have is what we're calling as user personalization. So a typical example here is you have a user coming onto your landing page, and you want to recommend 10 items from your catalog of 20,000 items which are relevant for this particular user, right? So Personalize solves this out of the box. So in this example here, I'm going to Prime Video and getting recommendations for the TV shows which are relevant for me, right? So I'm sure that as a consumer of, as a user of a lot of consumer websites, you must have all seen this experience. The second experience we solve is that of similar items. So let's say I'm seeing a particular item. I want to know what other items in the catalog are similar to this particular item. So in this example here, I'm seeing an area rug on Amazon.com, and it populates a list of other rugs which are very similar to this one, but not exactly the same, right? So this is very important for discovery of items in your catalog. And this is, if you're familiar with the experience on Amazon.com, this is the workhorse user experience or the dominant user experience on Amazon.com as well. And the third use case we solve is that of personalized reranking. So this is re-ranking of items for a given user. So typically, one of the applications is you want to re-rank part of your catalog within a certain category. So for example, here I'm on audible.com, and I want to get recommendations from only within the classics category. So this is, again, something which you can solve with Personalize. Now this list of candidate items can also be from a search query, and you can essentially pass the results to Personalize and re-rank them in effect achieving search personalization. All right, so let's go over the setup process. So the first part of using Personalize is adding data to Personalize. So there's two ways to add the data to the service here. So you can either bootstrap the service with the historical interaction data you have about the users, right? So let's say you want to start using Personalize tomorrow, and you already have 6 months worth of user clicks. So you can put that all that data in S3, and from S3 import it into Personalize. So it's a fairly straightforward thing, doable from console. Similarly, this is also the way you would import the user metadata and the item metadata sets we were talking about. So that's what you do to bootstrap to get started, right? But when you're using the service, we do expect you to send events to us in real time. So we have a put events API, which is accessible from server side. So if, let's say you already use Kinesis to stream those events into Personalize, it's fairly straightforward to then send those events additionally to Personalize via the server-side integration. But you can also send the events to us via client-side integrations, and that's accessible via the AWS Amplify library. And then the next step here is training. So here we have this concept of solutions. So you choose one of the algorithms according to the use case we discussed in the previous slide. And essentially, that's what you need to do. You already have the data in. You do a couple of clicks, and you get a trained model. For those of you who are curious to explore a few things under the hood, we expose several hyperparameters for featureization and for the algorithm, which help you tune the system for your business needs if you wish to do so. And then once the model is there, you get to the stage of doing inference. So we offer two forms of support for inference. One is, let me go back. Yeah, we offer two forms of support for inference. So one is real-time inference. That's via a concept called campaigns. So you create a campaign with the model which you previously created, and then you can vend recommendations for a given user, re-rank items for a given user, or get similar items for a given item using a campaign. But you can also batch process recommendations. So sometimes you have downstream applications which are more batch-oriented. For example, you might want to send email, promotional emails to, let's say, 1 million users, right? And it might be then, in that case, worthwhile to create just a single shot of recommendations for all your users and then feed it to your email system. So both the real-time mode and the batch mode is supported in Personalize. So let's now go a bit deeper into the use cases. So first talking about user personalization. So we talked about how this is relevant for landing pages, but this can also be used in several more scenarios. So one is cart recommendations. So when users are adding something to a cart, they are showcasing a strong intent. And we're using sequence models. I'm going to be covering more of that in the coming slide. So basically, having access to that information, we can generate fairly good recommendations of what other items to recommend to users to add to the cart. This can be used in email promotions. So let's say you want to send an email saying that come to our website, you get 5% discount on any of the items, right? But you might want to include the 5 items which are likely to interest the user the most, right? So you can use the same use case, generate recommendations for the users, and then send a personalized email to them while carrying the same promotion. And this can also be used in detail pages in addition to similar items, just as a complement to it. So this is how you use, this is how you solve the user personalization use case with Amazon Personalize. So you start off with adding the user item and the interaction data. And then you create a solution using one of these 3 recipes. So again, this is somewhat analogous to an algorithm. So we have 3 available recipes here. HRNN stands for a hierarchical recurrent neural network. So this is the base version, there is a metadata version, and then there is a special version for handling cold items. Then you create a campaign. We also ask you to do the real-time events integration. So we have real-time events coming in which let us change recommendations for a user. And a copy of these events are also persisted so that we can use it for further training of the model. For inference, you send us just the campaign ID or ARN for which you want to get the recommendations and a user ID. And we vend back recommendations, which is a list of item IDs for you. So this is where the boundary of the personalized system ends. Now you're getting back IDs. Typically, you might want to integrate it with another system, which is used to then look up, for example, the description of an item or the image of an item, and then you will have to render the end user experience for your users. So this can be used to render display experiences most commonly, but also any asynchronous offline experiences as well. All right, so let's see what's happening under the hood on user personalization. So we are doing user personalization by using sequence models. And the intuition here is that the evolution of interest and disinterest of a user is a good indicator of what they're trying to do in the future. So in this example here, we have users clicking on a few items. So they started off clicking on a shoe, and then they clicked on a few watches, right, or purchased a few watches. Now, we would typically expect that their intention right now is to shop more for watches, right? And so this would be the right kind of recommendation for them instead of this, right? So what we are doing is that we are using a recurrent neural network to learn from this sequence of user interactions. And then we are also adding information which is metadata about the user, so the context about the user and properties about the user, so their age and location, for example. And by combining this information, we get to a learned user representation. Now, when we do just a dot product of this learned user representation with the item vector, we get a recommendation score. So at inference time, we are essentially telling you which items are the most relevant for this particular user, given their latest interaction history and given this context information we have about the user, right? So that's what you get out of the box. Fairly straightforward way of thinking about personalization systems, but a lot of approaches for personalization actually miss this detail. So a lot of naive approaches don't take care of the order and timing information in personalization, and which leads to a severe degradation in performance because you're not responding to the user intent. So with sequence models, we are able to assign more attention to recent events, and we are able to learn how much more attention to apply to recent events. And this is real-time responsive. Then we get to cold item personalization. Think of it as a special scenario of user personalization where we have cold items. We don't have a lot of interactions against those items, and we still want to personalize them for a given user. So this is solvable by using the HRNN cold start recipe. And the essential idea here is that by looking at the user's past interactions, we know the kind of items that they're interested in. And then when we find new items which are cold, by looking at the metadata of those items, we are able to map and see which of those cold items are going to be relevant for a given user. So this example here is from the MovieLens dataset. It's a randomly selected user who has this interaction history. And we also simulated holding out some items and creating a cold item set. And then we are essentially able to tell which of these cold items will be relevant for this given user. So if you see this example, there are several items who have genres which match the interactions that the user has had. All right, now let's get to similar items, which is the second use case we talked about. So similar items is useful for things like detail pages. And you can have a lot of variants using similar items based on the kind of event that you choose to calculate similarity on. So you can have a simple experience, which is users who purchased an item X also purchase item Y, right? But you can also be a bit more, explore a bit more here and have widgets saying users who clicked on X also clicked on Y. So if you don't have purchase information about too many items, you can actually calculate similarity on view events as well. So allows you to mix and match things and create a lot of different personalization experiences. This is also what you commonly see on Amazon.com. So you have widgets showing you people who bought this, also bought this, but also things showing you people who viewed this, also viewed this. So solvable out of the box with Personalize. So that's the base experience, but you can also combine similar item recommendations with some business rules on your end to create experiences such as upsell of items. So you only want to recommend items which are similar to this given item but have a higher contribution margin, for example. How to use is exactly the same. So you start off with the data. Once you have the data for one recipe, you don't need to ingest it again. We can use the same data. Now you create a solution with the SIMS recipe, and you create a campaign. No real-time events are needed here. So if you want to do batch processing of recommendations, SIMS is a good candidate for doing so. And then you send us an item ID at inference time, and we return back a list of item IDs which are similar to this given item. So let's see what's happening in SIMS under the hood. So the SIMS algorithm is an example of item-to-item collaborative filtering. So I'm going to explain this with a few sweet items. So this is a donut. Doesn't look much like a donut. But we start off from a particular item, and we find users who have interacted with this item. So let's say these two users purchased the donut, right? And then we see which other items did these users purchase. So they also both purchased a cupcake and a toffee and an ice cream. So then we can, based on co-occurrences of purchases or views or whichever event that you're modeling on, we can calculate similarity between each item-to-item pair. Right? So fairly intuitive, straightforward way of doing personalization, but it has stood the test of time, and it's a very performant way of doing personalization. So an item is similar to another item if they were interacted by or co-interacted by with the same users. So SIMS is really scalable. You can feed in a lot of your interaction history to SIMS, and it scales really well. It also scales really well to a very big number of items. And a good point about the SIMS algorithm here is that we don't need item metadata to calculate similarity. So if you have your catalog where the data quality is in doubt, you can still calculate item similarity with a lot of confidence by just observing the user behavior. And SIMS, though it looks simple, can also be fairly challenging, because a common issue here could be that if I have a popular item, let's say a bottle of water, it is purchased by everyone, right? And it will co-occur with every item. So essentially, we are doing a balancing act between popularity and correlation of items. So we have tuned this system such that it works out of the box for a vast majority of use cases. But we also expose the knobs to you if you want to tweak things and you want to change the popularity versus correlation trade-off. All right, so personalized ranking. When to use is category-based recommendations, as we talked about the Audible use case, where we were getting recommendations for only in the classics section. And it's also useful for recommendations under certain business constraints. So for example, I only want to recommend free-to-watch movies to a certain user, right? Because I believe they're going to churn out if we ask for more charges for showing some things to them. So it's useful in those scenarios. Very similar use case again, so you don't need to ingest the data again. This data is already there from the previous recipes. Then you create a solution using personalized ranking recipe. You create a campaign. Important to have real-time events here because that's how the relative ordering of the items is going to change as new information comes in. And then for inference, you provide us a campaign, a user ID, and a list of item IDs to re-rank. And then we re-rank the list of item IDs for that user. So this is a brief summary. And this is also a sequence model under the hood. So very similar performance characteristics to the HRNN algorithms, which I explained earlier. So this is Personalize in a nutshell. Now let's hear from a few actual customers on how they have been using Personalize and the kind of results and experiences they have had with Personalize. So I'll hand it over to Emerick now to walk us through Voodoo's use case of Personalize.
Thanks. Hello, everyone. So I'm Emerick, CTO of Voodoo. So you probably never heard about Voodoo, but I'm pretty sure that you or someone in your family is actually and actively using our products. We are the #1 gaming company with the most downloads on the App Store, the second mobile company just after Google. And since 2018, we released 160 games that has been downloaded more than 3 billion times. So the games we create are pretty simple, they are fun, and everyone can use them. It's super easy to understand. You don't need to be a pro gamer, so you can play them anywhere, anytime. Maybe you are playing them right now if this talk is not interesting enough. Our games include titles like Paper.io, Aquapark, Snake vs. Block, and our bestseller, Helix Jump. And when we look at Helix Jump, it's a pretty simple game, but that simplicity is actually where the complexity is hidden. So I know it's hard at the first glance to see how this bouncing ball could be a technological challenge. And yet, we need first to deal with scale. Those games are played by more than 300 million users every month. They are sending more than 1.5 billion data points every hour. So even though it seems like our biggest technological challenge, it is not. Our games are so simple that just after a few months, our users need something else, something new. And our biggest challenge today is find a way to repeat the success. Find a way to release hit games after hit games and after hit games. And so to explain to you how we do that, because you can release one hit game with luck, but you can't release 160 games with luck. You need a culture, you need a process, you need tools. And to explain to you how we managed to create that, I'm just going to share with you like a very quick story that happened in the early day of Voodoo. So we started working on 2 games, very similar, and everyone at the office was playing the first one. Nobody was playing the second one. But even though our CEO insisted to release the 2 games and see what happened. And surprisingly, the game everyone was playing at the office was a total failure. Like, nobody played that game. And the other one, nobody was playing at the office, was a huge success, downloaded millions of times. And since that day, every decision we take at Voodoo is data-driven. Data is key. Every assumption that we have, we test it, gather data, and decide on what to do based on that. This experience is how we manage to create our culture and how we manage to create our process. The process is like very simple. We need to go fast. The first version of our games has been created in just like in 2 or 3 days. We know we are going to fail, but thanks to data, we learn. We always learn. So we fail, we learn, we fail, we learn, until we have the right game that is going to be fun, that is going to be played by millions of users. And then you need tools and also data to scale, to promote the game to like anyone in the world. After creating that process, we started now to expand that beyond hyper-casual gaming. So we started using the same process and the same data to more advanced games, but also to non-gaming apps. And one thing that all those kind of apps have in common is data, and especially recommendation. So now I'm gonna let Robin explain to you how we manage to use recommendation for two of our main use cases. The first one is promoting our apps to our existing user base, and the second one is optimizing our apps and optimizing our game to provide a personalized experience. Thank you.
So hi everyone. So I'm Robin. I'm tech lead at Voodoo, and I'm here to talk to you about a little bit more about how it works in the true life. So the first topic I want you to know is our cross-promotion system. So what is cross-promotion? Cross-promotion is really how we can promote our games in our own games. So we want to leverage our own user base, so dealing with like a low acquisition cost of our user, because when you see hyper-casual market, as you can see, we have a big part of it. So when we're launching a new game, there are a lot of chance that the user will be already in our games. So what it means a lot of data challenges, because we need to know if it's more viable for us to show an ad for our own game or show an ad for another application. So for that, we need a true recommendation system. We have a massive scale and high viability, because if we mess with all the advertising process, we lose money directly. And as we have hundreds of millions of users, it could like have a huge impact on our revenue. And we need to process like terabytes of data on a daily basis. So we need like our model, a lot of features, and a massive scale. So for that use case, we chose SageMaker because it was flexible, scalable, and it also be a managed solution. So it allows our data scientists to be autonomous, to train and test their own data offline thanks to notebooks, then train their own model and A/B test it in SageMaker endpoints. The other use case, so it's like real-time prediction. So it's really all about that. So we predict bid in real time. We have like more than 100 daily calls to million daily calls to our SageMaker endpoints. Even each call will do dozens and dozens of inferences, so it means billions of daily inferences. So our next use case is the non-gaming apps. So as Emily said, we want to diversify our business. So for that, we want to try the non-gaming application market. But we want to keep our strong culture. So we want to bootstrap app very quickly and iterate very fast until we get the perfect match. But what we very, very quickly saw is that if we don't have recommendation for content-based application, it just doesn't work. If you have a video app and you don't show the right content to the right user very quickly in your application, the user will just churn. And so we need more like a framework of machine learning. And for that, we are choosing Personalize. So it's very easy to use. It's very fast to set up. It can handle many use cases out of the box. So it's just machine learning in a few steps. You just collect events from your app. You create your own data set. It's depending of if you want to like make more clicks, more views, more likes. You choose really what you want to improve. You prepare your endpoint through the Personalized console or with the Boto3 SDK or any other API calls. You deploy your model and you can call Amazon personalized endpoints for inferences. So if I deep dive a little bit more about our stack, so the first thing is data collection. So our app will just sending events to our data collect stack. So it's just an API that enrich the data a little bit, sending to our firewall stream. Then it just store it in S3. So S3 is really our data lake. So only that, we can go to data transformation. So we want to make sure to schedule job because for now we are in the batch mode. So we just popping some EMR with Spark jobs. We create data set for each machine learning processes. Then we store those data set on S3. Then come the personalized part. So we still schedule the training part. We just use Python and Boto3 to just upload our data to the personalize, train the model, choosing the right one, then deploy your endpoint. Once the endpoint is just deployed, we get just call inferences from our apps through our API. So next step will be really to try the real-time recordings stuff about Personalize, and also try to choose Amplify in our apps to directly call Personalize without having one of our own API in the middleware. So the benefit of it, we saw global improvement of the retention of our user in our apps directly. We can just focus on new features, on UX, on UI, on one bring our apps unique, and you don't have to take care of the recommendation. And it also enables us to just stick to our culture and make fast iteration. So what I want you to take away today, guys, it's several things. First, we are early adopter on AWS services, that is Personalized, and it's like both sides of a coin. As you are an early adopter, you don't have just right away all the features you need, but it also means that you work directly with AWS, so you can make the product evolve the way you want it, or at least just go the right way and see how it will evolve with the future. The other thing, and it's also why I talked a little bit to you about SageMaker before, it's always choose the technology that's suiting your use case. If you need like a quick framework to do machine learning and personalization with multiple use cases, and you need to focus on something else than recommendation, just use Personalize. If you need like complex data scientist work, etc., choose SageMaker or another product that suits your needs. And finally, really, data is key. So if we see the overall machine learning process, we can see that all that part is the machine learning process, how we train your model, you put your model online, you monitor them. But don't forget of the data collection process. So all this process is really the key to your success with machine learning. You need data with high quality, because there are some basics with machine learning we need to never forget, is that garbage in, garbage out. So thank you, guys. I will let Mark from Coursera show them his use case.
Thank you. Good job. Good afternoon. I'm Mark Chamness. I'm the Director of Data Science and Machine Learning at Coursera. Now, I want to thank you. I realize I'm probably the last speaker before happy hour. So thank you for bearing with me. So, to give you some context about Coursera, it is a global learning platform. So today, Coursera provides online learning for over 40 million people worldwide. And it may not be obvious, but education is not universal. There are many people, not only in the US, but around the world, who don't have access to education. And so today, Coursera has democratized education. So from remote areas in India to China to South America, anybody can go online and take world-class courses, as well as get degrees. Today, anybody can get a master's in computer science from UPenn and earn an Ivy League degree anywhere they are, and they can do it all from their mobile device. In addition, over 2,000 businesses have hired Coursera. And what we're hearing is that businesses are facing challenges keeping up with technology and keeping their employees with the right skills at the right time. Technology continues to evolve, and they continue to need to evolve their workforce. In addition, we're seeing the same needs from major governments worldwide. Coursera has partnered with countries from Singapore to Egypt to Australia, and they're facing the same challenge of keeping government employees up to date on modern skills and technologies. Over 170 of the top universities offer courses on Coursera. Yale University, Harvard, Caltech, Stanford, the list goes on and on. The top high-quality universities. And this extends beyond the US to Russia and China. We have partnerships around the world. And this is the latest university in India to show some of the diversity. And we have an audacious goal to reach the other 20,000 universities and be the platform that allows them to put their courses online. Here are some examples of the world-renowned faculty. Famous Professor Andrew Ng of Stanford University, teaching a machine learning course. A Nobel laureate from Yale University. And I can go on, but these are some of the examples that anybody in the world can take today very cheaply, economically. They can take a course, they can take a master class, and they can get degrees. So what changed? I've been doing machine learning for 25 years. And this past year, something changed dramatically. At my previous employer, I had a senior data scientist, very experienced woman. She spent 3 months building an advanced chatbot, integrating with Slack and doing testing. And then someone said, you need to talk to some guy down the hall. So I went down the hall, found out someone else had built a better model. It was an intern, and he did it in 1 week using Amazon machine learning services. Then a light bulb went on. The world has changed. It's not the same anymore. So I want to speak to you about some of the nuts and bolts, some of the business challenges that we face at Coursera. So we have over 40 million learners actively using the platform, and we need to provide recommendations for them. In addition, we have 4 million unique people visiting Coursera every day, and they expect the same type of experience they get on YouTube and other platforms, tailored to who they are and their experience. We have hundreds of millions of events in the past that we can leverage, and so we want to use all that data to build the best recommendation system that we can. And of course, all this has to happen in real time. And, oh, by the way, it can never fail. It has to be a highly scalable, highly available solution. So let's talk about a specific example. This may be the most popular online course in the world. This is the machine learning course from Stanford. You can enroll for free. You can take it right now. And so how do we get better recommendations? By feeding into the Amazon personalized recommendation engine. So as you've seen, we have this large history of events of what people have observed. And it's very simple to feed those into the engine and then give it a course ID. It will actually spit out items which are similar based on human behavior. So here are some real recommendations from Amazon Personalize. And intuitively, these make sense. They call this the SIMS recommendation engine, similar items. And so for the machine learning course, it recommended the deep learning course, applied data science with Python, machine learning, and neural networks. All these are highly relevant and are natural fit for someone who's looking at a machine learning course. So one of the questions I get is, why Amazon? There are lots of recommendation systems online. You could load some library, you can hire a third-party service. Why Amazon? Well, the evidence is pretty astounding. Amazon's been doing this for 20 years, and I don't know of any other company that has that much experience at that size and that scale for recommendation engine. We could buy the best recommendation engine in the world, so why build it? I'm going to go into a little deeper into the nuts and bolts. Here's our architecture. It's going to look very similar from what you saw with the earlier speakers. All of our eventing data is in Amazon Redshift. We export from Redshift to an S3 bucket. And then from Amazon Personalize, you can start an import job to bring the data into Amazon Personalize. And for 50, 100 million records, That takes about 30 minutes. It does a lot of pre-processing and filtering on the back end. And then you ask the model to train. And then we have our own A/B test harness, and we're able to compare users who are automatically assigned to either the Amazon Personalized recommendation system or our baseline, our legacy recommendation system. And we could do this and watch the statistics change every hour, every day, and see how it performs. And we can also change the hyperparameters for Amazon Personalize, redeploy, and see how that behavior changes. And we definitely found an impact. So this is the code behind that architecture. And so I'm not going to read through every line of code here, but I just want to show you it has the same basic steps. So import the data, start the model training. You can evaluate the model that you generated. You can evaluate its metrics and see how well it performed. And then you can deploy that model to production. What I wanted to show you by this slide is that an intern can do this. Voila. So we ran into a technical issue, which is really interesting. So this is a histogram of page views, and any online service, be e-commerce or digital content, is going to have the very same long tail issue. We call this the power law. And when we first trained the Amazon Personalized model, there were some courses that had 0 recommendations, or they just had very few recommendations. And so after consulting with the Amazon team and saying, hey, I think there's a problem with your model, they said, well, you need to tune the hyperparameters. And so it turns out that many of the hyperparameters are there to help you because they filter out what are considered anomalies. And so what's an anomaly for an e-commerce site is different than what's for an online digital content site. And so by just changing one of these parameters from the 1 percentile to the 10th of a percentile, it fixed the problem. And then all of a sudden, the recommendations were there for all of the courses. But the advantage is that it scales out. So I can change a hyperparameter, and it scales out across 20 computers and returns in under an hour, so I get 20 hours of work done in 1 hour. I can change the hyperparameters again, retune, retest, iterate very quickly, and see what the results are. So this is one of the things that change is just the pace of development is much, much faster. The total time of development, most of it was the data engineering part to get the data in the right place so we can absorb it into Amazon Personalized. It was probably a total of 3 days. And naturally, it's Amazon. It automatically scales out. And so we have perhaps hundreds of hits per second throughout the day, and much fewer than that during the night, and it automatically scales with our needs. And we did an A/B test and showed increase in revenue. We're going to extend this to a more advanced model. Amazon calls this the hierarchical RNN. It's a metadata recipe, so you get metadata about your users, their browser language, the country they came from, the region, whole sets of data. And then you get data about your items, right? For Amazon, that's things you buy. For us, it's courses. So we have courses in Russian. Maybe it's a data science course. Maybe its subdomain is data analysis. And then we have the history of hundreds of millions of interactions of people who had Russian language browsers and looked at Russian language courses. And we feed that into the model, and it automatically learns what people look at. Given this type of profile, this is what they tend to look at. And it's a very personalized model, and it can also do it in real time. As a new user comes to your site, you can send their information into Amazon Personalize. The model learns. It's a deep neural network. And then it immediately starts giving more and more relevant recommendations as they click through your site for someone who's never come to your site before. So that's the power of personalization with this new engine. So let me show you what the results were. Here is the recommendations for someone I picked who had a Russian language browser. a random cookie, and obviously all the courses were in Russian language. And so it shows you how it can automatically find not only their language association, but I also found that people who were interested, for example, in JavaScript, it found Russian courses in JavaScript and English courses in JavaScript, so it correctly identified the domain that they're interested in. So this is some of the reasons why I'm excited about the Amazon personalized models and looking forward to more of my requests to them over the next year. Thank you, and back to Abhinav. Thank you.
Thanks, Mark. So Personalize is really easy to get started on. So we would encourage you to get to our website and give the service a try. We also have a lot of code on our GitHub repo. So this goes into details of all the use cases I discussed. It has sample data sets. You can just click through it. Fairly easy to get a sense of the service. We also, for the more advanced users, we also go into details of how models are characterized in performance. And we also have samples on how to benchmark Personalize's performance against systems you might already be using. So give this website a visit. If you are interested, we have several partners here who already have a lot of expertise on Amazon Personalize. And I would request these partners to stand up in the audience. And not too many here, few. Okay, so if you're interested to work with AWS partners with expertise in personalization, these are a few of the names of partners you can approach. And with that, we are opening this to questions.